friends, thank you for joining me. Welcome to TJ's Maths Clinic. In today's presentation, we continue with our solutions on this elective mathematics, WAEC 2025, January, February. This is for private candidate. With us here is question 11. In my previous video, I have solved question 1 to 10. Let's consider this question 11. This is the entire question, and this question carry 13 marks. This is further mathematics. Let's look at how we can handle this. The question reads, the gradient of a curve which passes through this point T, which is given as 3, 4, is given by change in y with respect to change in x is equals to 12 divided by square root of 6x minus 2. We are asked to find the equation of the curve, that's A, B, find the equation of the normal to the curve in A. This is from differential calculus. Let's look at how we can solve this. First thing to do, let's write down the solution here. We have the gradient here, and we are asked to find the equation of the curve. It means we have the derivative of a function here. This gradient is the same as the derivative of a function, unknown function. So for us to find the equation of a curve, we have to find the original function. And when the derivative of a function is given, to find that function, we have to integrate. So we have to integrate this gradient to get the original function. Very important. That is, we have the derivatives. Going back to the function now is like finding the antiderivative of these derivatives. Very important. So we have dy by dx, which is equals to 12 divided by square root of 6x minus 2. Very important. At this point, to find that function, we have to take the integral of both sides with respect to x. So let's take the integral of both sides. This is the integral sign. With respect to x, this will be equals to the integral of 12 divided by, let me write it this way. Let me write it very well. The integral of 12 divided by square root of 6x minus 2 with respect to dx. Let's take it up. Of course, this will divide this. We're left with the integral of dy now will be equals to, we can write this as the integral of 12, the integral of 12 divided by 6x minus 2 power half with respect to dx. Let me concentrate on the right hand side. Anytime you are asked to integrate a given function, this is a rational function whereby we have numerator and denominator. You have to check the denominator. If the denominator has only one term and it is chain, we use normal integration. But if we check this, we have two terms in the denominator and it's chain because of this power half. So we have 6x and we have minus 2. We have to use u substitution to integrate this. That's when to use u substitution. But if the term in the denominator is just a single term and it is chain, to find the derivatives, or no, to integrate, we have to use normal integration. Very important. So this is the same as the integral of dy is y. This will now be equals to, let me concentrate on the right hand side. On the left hand side, yes, on the right hand side, let u be equals to 6x minus 2. I'm using u substitution now. So we differentiate this with respect to x. Du dx now will be equals to, the derivative of this 6x will be 6. The derivative of a constant minus 2 will be 0. So we have du by dx is equals to 6. Let's make dx the subject. Okay? So to make dx the subject, we'll have dx as 6 du divided by 6. So first, we let u to be 6x minus 2, then we differentiate, we have 6x, then we make dx the subject of the formula, and we have du divided by this 6. So the next thing is to substitute. We have the integral now of 12 divided by u power half multiplied by, in place of the x, we put du divided by 6. 6 here, 1, 6 here, 2. Then let's take these two outside. We have 2 now, will be the integral of 1 divided by u power half with respect to du. Very important. So we'll have 2. It will be the integral of u power minus half using negative law of indices now multiplied by du. Very important. So let's integrate this. The integral of this now using general formula of integration, which is giving us, if we have function y equals to x power n, the integral of this will be x power n plus 1 divided by n plus 1 plus the constant of integration. So we use this general formula of integration. So it will be 2 into u power minus half plus 1 divided by minus half plus 1. Then plus the constant of integration now. Very important, okay? Let's move here so that we can work on that. This will now be 2 minus half plus 1 multiplied by u power half, because divided by minus half plus 1, of course, will be half. We close the bracket plus the constant of integration. These two will go up. We'll have 2 into 2 multiplied by u power half plus the constant of integration. But our u from here, you can say, but u is 6x minus 2. So let's substitute. Then we'll have 2 now into 6x minus 2. Let me factor out these 2 out before substitute. That's 2 times 2 is 4. So it will be 4 into 6x minus 2 power half plus the constant of integration will now be equals to y, because the integral of the y is y. So, but for this is now the equation of the curve, but we have to find this constant of integration. Let me clean here. To find this constant of integration now, we have to use this point. We have, this is x1 and this is y1. So let's substitute when x is 3 and when y is 4 using this point now to find the constant of integration c. So it will be 4 into x now is 3, 6 times 3. Let me use square bracket so that we can expand very well. It will be 6 into 3 minus 2. We close the bracket, power half plus the constant of integration will be equals to 4. And this will be 4 into 6 times 3 is 18 minus 2, that's 16. That's 16 power half plus the constant of integration will be equals to 4. Square root of 16 is 4, that will be 4 times 4 plus the constant of integration will be equals to 4. This is 16 plus c equals to 4. C now will be 4 minus 16. C will be equals to minus 8. Minus 12 rather, minus 12. Because 4 minus 16 is minus 12. So finally, the equation of the curve now, we can say the equation of the curve, now will be y equals to 4 into 6x minus 2 power half minus the constant of integration, which is minus 12 now. So this will be the equation of the curve. Y equals to 4 into 6x minus 2 power half minus 12. So this is the solution to A. Next, we are asked to find the equation normal to the curve. Let me clean here. The equation normal to a curve is giving us the formula now. Equation normal to the curve let me write it here. The equation, the equation that is normal to the curve is given as y minus y1 will be equals to m2 into x minus x1. So this is the formula we're going to use. So it means we have to find m2, okay? Given that we have m1 here. Very important, given that we have m1 here. So our slope m, which is the center as m1, is equals to 12 divided by square root of 6x minus 2. And we know our x as 3 is given from the question. So we can find m1 now, which is 12 divided by square root of, that's in place of this x, we'll say 6 times 3, that's 18 minus 2, that's 16. Square root of 16 is 4. 12 divided by 4, that's 3. Let's do it again. 3 is our x, 6 times 3 is 18, 18 minus 2 is 16, square root of 16 is 4. 12 divided by 4 is 3. So our m1 is nothing but 3. Okay, m2 is nothing but minus 1 divided by m1. This will now be minus 1 divided by m3. And our x1 from the question is 3, then our y1 is 4. So we can easily find the equation normal to the curve now. And let's substitute into the formula now. Let's substitute into the formula. Y, we have our y minus y1 is 4 will now be equals to m2 is minus 1 divided by 3 into x minus x1, which is 3. Let's clear this fraction. Multiply through by 3, which is the LCM now. 3 times y, that's 3y, minus 3 times 4 is 12, will be equals to, multiply 3 by the whole of this. This 3 will take care of this. We're left with minus 1 into this. Minus 1 times x, that's minus x. Minus 1 times minus 3, that will be plus 3. Let's rearrange everything and equate it to 0. This will be 3y. This minus x crossing the equal sign will be plus x minus 12. This plus 3 crossing the equal sign will be minus 3 will be equals to 0. Finally, the equation normal to the curve now will be 3y plus x minus 15 will be equals to 0. So this is the equation that is normal to the curve now. So this is the solution to this question. Thank you for watching. Please do share this to your learned colleagues. And don't forget to subscribe to TJ's Maths Clinic for more interesting videos. You can follow me on TikTok, Instagram, and Facebook. Thank you for watching. See you in my next video.